Hello everyone and welcome to Module 1 in Monte Carlo, which talks on Monte Carlo simulation techniques in advanced statistic algorithms, I think it is. So, statistical techniques. So, I thought I'd start with going through quickly the course room. It looked like everybody's already kind of kicked off the first bit, which is where you go through and do the learning plan, because that's the first step. Pretty much click view and then talk about, well, which feature will help you. And so probably most of you are going to say that. No points, but this is just to get you started, and you've already done that. I believe I saw everyone had completed this. So after you've done that, then the obvious next step is to go through and start poking around, taking a look at the various assignments that go on and paying in particular attention to the course project assignments, because that's where the points are in this course, as I'm sure you all know. So the first topic we're going to talk about is Monte Carlo simulation. We'll talk about that in a moment. Fancy name for something that's pretty simple. That's kind of going to be a reoccurring theme on some of this stuff, and hopefully I can keep it to where it does seem simple. The next thing we'll talk about will be Markov modeling, in particular essentially Markov chains to manage state transitions in a probabilistic way. And then do some PCA, principal component analysis, talk about some decision trees and some Bayesian stuff. A little bit of oddness there, because the assignment you're given, deliverable 4, does construct a tree, but it's not exactly a Bayesian tree. So it's interesting. We'll talk about it and go from there. We'll talk a bit about regression, then we'll talk about validating models, and then we'll move into your deliverable 7, which is insurance analytics. So those are the high-level things we'll be talking about through the deliverables. Again, we're in Monte Carlo. Again, look like you guys are old pros at using this environment. If you're new to it, do remember that your syllabus is over here hidden underneath books and tools. Click on that and then click on syllabus if you want to take a look at the syllabus, although in most of these CBE courses it's a very similar sort of thing. You 6% for doing the live faculty sessions, and then 11% each for the deliverables 1 through 6 and 28 for deliverables 7. And thank you, John, for joining. I appreciate that. If you have questions as I'm going, John, feel free to stop me and ask. It's only useful if you guys get something out of it. So
yeah, you bet. Nice to meet you. Pretty excited about this one. This is a really cool class in terms of subject matter. So
yes,
nice to be working on this with you.
Yeah, glad you're here as well. Yeah, it's a cool course with a scary title, right? A lot of people,
Yep.
a lot of people when you see advanced statistics, they go, "What?" Although I've learned over the years,
Right.
beware of the course or beware of the book that has fundamental in the name. That is the one to really watch out for, because advanced probably may not be all that hard, but fundamental could be a real painful experience.
Noted.
So back and we'll go through this quickly, and then I'll spend most of the time probably doing some demos, right? So we'll go through this
Cool.
and then see it on hand. So this is pretty much talking about what's the point, right? And it's using Monte Carlo simulation. So you might ask yourself, well, what is it, right? So named after, a casino, and guess it's Monte Carlo, right? So the basic idea, though, is about doing iteration, so repeated trials of something, and then calculating what, or observing and determining what occurs most frequently. So basically a loop, saving up some values and then doing some analysis on those values. That's the gist. When do you use it? If things are too complex for something else. So it's one of those things that it is a form of simulation. So that means it's an approximation. So it's going to be pretty good, and it may be the thing that works because it is the thing that works, right? So generally speaking, it will use sampling with replacement. So you need to understand what that means. Pretty simple stuff again, but we'll talk about it just because sometimes things get forgotten, as it may have been a few years. And it's used in lots of different domains. The handbook for Monte Carlo simulations, pretty good. I took a look at it, not bad. And then there's a link there in pbpython.com/Monte-Carlo HTML. Also pretty good. It's Monte Carlo simulation is one of those things that is very popular, probably because it is relatively simple to understand. Booz Allen created a consulting firm, a component or a plugin that you can put into Excel if you want to just play with something in a simple way. Although realistically, it's not all that necessary, but it is kind of cool. It does give you a sense that it is something that the people use in the field quite a bit. Your key takeaways. The loop is the secret sauce. That's what makes it Monte Carlo. And it's all about multiple iterations and doing some sampling runs. So that's kind of the key thing. Now, for something a bit more fun, we'll do some demos, and then we'll come back in a little bit and talk about the deliverable, the first deliverable. So as soon as I find the right window, let's just click. There we go. That'll work. We'll go through, start off with Python, then talk about R, and then SAS. A key thing that hopefully it's not missed by you guys is to get the A in this course. You've got to do the assignments basically in 2 languages. So shouldn't be a big surprise. Not all that dissimilar from the Intro to Data Science languages that I also teach. Your choices, the 3 to choose from, and I might could be persuaded to talk about a different one if there's something that is a compelling argument, but is Python, R, and SAS. What I've done for SAS, because I don't particularly like using the web thing, which is your choice now, I installed the product called WPS, World Programming something Systems. Anyway, a kernel into Python, into Jupyter, that lets me run those SAS programs inside of Jupyter Notebooks, primarily because I like doing things in one place. So we'll start off and talk about sampling with replacement in Python. So yeah, some fairly complex stuff. So I'll go ahead and step through this. Typical get NumPy and pandas, although I don't know that I'm actually using pandas. Maybe just copy paste code. Oh, yep, I don't see any pandas. Anyway, so basically generating a list, and this is taken pretty much from your materials, this, an array of essentially 7 things. Oh yeah, we are creating a panda data frame there from those columns. And then basically with replacement is as simple as doing the sample method, and that may be a little small, so let's get a little bigger. Hopefully that's easier to see. So sample, and you pass in replace equals true if you want with replacement. And you'll see that you get back when that's ran each time a slightly different sample with replacement, and that's because I'm not doing a setting of the seed, so it's truly random. So that's basically with replacement. It means whenever you grab an M&M out of the jar and you pick I don't know 4 of them, and you see what colors they are. After you're done with that and write it down, you put them back in the jar. That's literally it. So it's that simple. When we talk about without replacement, what we're saying is we're not putting it back in the jar. So if you have 10 M&Ms inside of the jar and you pick sets of 2, you're going to stop after 5 pulls, right? So because there's going to be out of M&Ms. So that's the basic idea here. And if you do something interesting and say, oh, gee, I want 10, and I'm not doing replacement, it's going to yell at you and tell you cannot pick something bigger than the population. So that is sampling with replacement. So real complex stuff, and again, here's where that error message I generated was saying basically the same thing. So generally speaking, you're going to be doing with replacement. There could be exceptions. None is popping to mind right now, but that is sampling with replacement in Python. Then moving into some simple Monte Carlo stuff with a loop. The basic idea here, do some stuff so we can get some visualizations. This is taken from, and this is one of the things I recommend, that if you find inspiration, I'll say it that way, with something online, to avoid the possibility of bad things happening, include that in a comment or a markdown cell, similar to what I'm doing here. That way there's no question of you attempting to not attribute ownership of an idea to someone. So it may not come up, although have had times in the past where people sometimes fall prey to that. So that's where this came from. And so basically, you'll notice here that it's a nice little way, and if you're unfamiliar with Jupyter, although most people at this point are pretty familiar, it's a nice way of blending together code and comments and output, right? So we go through and we basically set what we want it to look like, set the parameters, the number of simulations, and so on, and then the start doing the kind of the magic stuff. And when it's all said and done, there's something that does the loop, and then you'll start seeing some results. And so that's the basic idea. This one's not quite as compelling as some, but it is worth taking a look at, right? So your basic idea is that, here's our loop. So you run something in a loop. You get back some random choices, and with typically something that models the thing that you're doing. So if you're modeling somebody playing, taking the casino bend, if they're doing the one-armed bandits, and there's a 49% chance that they'll win, that allows you to do the simulation, right? Because you then basically use that 49% is the probability of success. You keep track of the number of times they win versus lose, and then figure out how long it takes them to run out of money. And that's one sort of approach in a random sort of way. This is doing something very similar. It's basically figuring out sales targets and percent to target, constructing a data frame, taking a look at the results, and then so on, and then plotting it out. And not surprisingly, because up here we're using something with a normal distribution here, you end up with something with a pretty normal distribution. And that's basically it. So a little more compelling ish is this one. And it's interesting. I asked this question way back when I was in high school. Well, how do you figure out what pi is, right? We know it's 3.14 and a whole bunch of other numbers, and it never repeats, and it's a rational number or whatever it is, and so on. But how do you come up with that number? And so this is an approximation of doing that using Monte Carlo, right? So the basic idea, and this is a simplistic one, and again, you'll notice I took this from here, hands-on simulation. This is in our, I believe, packet was in our the O'Reilly data set that we our set of information we have access to, so it's very compelling. So basically, you've got here the probability is the number of event occurrences over the total number, right? So that's kind of common sense. But the magic here is whenever we come up with putting a circle into either a 1 unit box, basically. So you've got a box where you've got a circle that's got a radius of 1. The box has an area of basically, 2. So you come up with a formula for pi is equal to 4 times m over n. And so that's the magic formula that we use then to go through and do the calculation. So this is probably, again, it's not practical. You're not going to calculate pi because you use math.pi if you want to know pi. But it is kind of cool, right? So what we do here is we keep track of the times that something hits inside of the circle and the times something is outside of the circle based upon a formula of knowing where on a given xy coordinate if it's inside or outside of the circle. That's the basic idea. And you roll the dice enough time, or it actually started off with, I believe, a pin drop was the original way that it was simulated to produce the values. So if we start off, just to show it in its cruder sense, we'll start off with 50, right? So we're going to run it 50 times, and we don't have any instances, right, because that's it hasn't hit. And then we clear out our arrays, and then we basically have a loop here that's going to loop through it, generating a random number, using this formula to determine if it's inside of the circle or it's outside of the circle, right? And that's the basic thing. And this line here, this is the Monte Carlo, right? That is, if somebody says, what's Monte Carlo? It's that right there, right? You run it, and then you can calculate a pi, pretty crude guesstimate there, 2.72. And we can actually see what it looks like when it drew it, right? So a few points, but not enough to really get a sense. And the yellow ones are the ones that are inside the circle, the blue are out, right? Then we can take it up to a higher number of iterations. So let's say we're going to go 200 just to keep it interesting, right? Clear out our arrays, do the loop again, calculate a series of random XY coordinates, and then determine if they're in the inside of the circle or inside of this outside of the circle, but in the square, which they'll all be inside of the square technically. And then we can see pi is a little better, 3.18, so definitely a more accurate estimation. And then we can see additional drawing of it, so we're getting a better sense of where they are. So then to skip ahead to say 1,000, just to go ahead and move it along more quickly. And then we can see pi is at 3.19, and we're starting to fill it in more. Let's go ahead and do 10,000, and that's the beauty of iteration. And you can start seeing it's taking shape, and also it's approaching 3.18. We'll go ahead and do 100,000 just to kind of complete it out, and that should fill in the circle nicely. Came out to 3.14, and nice solid indication of where the line is versus where the things that fell on each side of it. So pretty cool instance, but the key things to make it all happen is you need to know the number of times you want to loop and the formula that's being used to do essentially your determination, so the outcome, the yes/no sort of thing that you typically keep track of. And that's basically it in a nutshell. Kind of cool, kind of simple, fancier name than it actually is, right? So at this point we've talked about Python with simulation. Let's go ahead and take a look at the small biz simulation as well. I can't remember if I have that installed or not, so we'll go ahead and run through these. Looks like they're already installed. All right, let's see, is this going to work? Should work. So the first thing I typically do whenever I'm doing these sort of exercises is what we're doing is loading in this BizLoans CSV. This stuff is in your course room as well. I generally take a look at it, kind of do a quick sort of display to see what it looks like, to get a sense of the columns and so on. Then I do a info probably to make it a little easier just to see what they look like. And then here we can basically pick essentially 1,000 items with replacement to create a data frame, right? So that's basically essentially a sampling sort of thing. And then no real point of, I guess we can look at the info on that too, but it's going to look pretty much like the other one, right? Because it's just a sample. And so it's a subset of rows, potentially, depending on how many was in there to start with. Yeah, it's a subset because there was 5,800 or so, and we picked 1,000, but we picked them with replacement, so there could be duplication of the rows. Then we can take a quick look of what they look like. And this is basically, the small biz is around prediction, essentially, of default on a loan, right? So if you're loaning money to a small business, there's some factors that go into are they likely to pay you back or not? And you can model it with Monte Carlo. And interestingly enough, Monte Carlo has been used quite commonly in things like this sort of stuff for quite a while. There are some challenges. It may be a little hard to explain, and explainability has become very important whenever we're doing any kind of machine learning. So what this is doing is, okay, we then separate essentially our train or not our train, our targets and our values, so our features and our target into the X and Y, and then we can build a random forest classifier off of it. And then we can basically tell it that build the features that we want with 10, right? And figure out that we score it off of accuracy, and it's going to go off and do basically the work here for us. And so running through the number of iterations we told it to do, which I don't see off the top of my head. I'm sure I scrolled right past it. But so then we get back some value of the names that are, and I was looking for this earlier, that are contributing to the prediction the most in a way. So that's what this is about, is figuring out essentially feature selection of what features are going to be the more compelling whenever you're talking about doing that classification. Part of the reason why that's interesting to me is I've been doing some side research on detecting plagiarism in written text using natural language processing and statistical methods. And you can come up with a whole bunch of different statistics around text, but it's kind of challenging sometimes to know what really is useful. So what this is doing is actually iterating through, running through and trying various ones of those features and figuring out which ones are doing the better. When it's all said and done, it'll finish. I'm not sure how long this one takes. But while it's running, we can go ahead and shift over and talk about R, I think, because that's about it for Python. R, similar sort of concept. And the start off with sampling with and without replacement. Syntax is a little bit different, obviously. And yes, I was lazy and used the equal instead of the arrow. But anyway, so similar sort of thing. You've got a sample method called sample, and with a parameter called replace equals true. Makes you wonder where Python got their idea from, right? So we can basically go through and say pull 5 records with replacement, and if I run that again, they hopefully won't be the same. So it is pulling different ones, and you can see we are getting duplicates here of G and C, and G and C being duplicated. With out. All right, that's nice. Without replacement, so we got replace equals false, and with that, it's going to pull them, and there should be no duplicates, right? So if we run it multiple times, we'll see we're not getting the same stuff, and more importantly, we're getting different values, so there's no duplications. So that is sampling with and without replacement. So there's not a very advanced statistical topic for our advanced statistical course. Looking at the small biz loan as well. Did this finish? Yes. So looking at the things that you should consider if you're deciding if you're going to loan people money or not terribly surprising, is how many years that they've been in business is a pretty good indicator. So more likely than not, those that have been in business longer are less likely to go bad, or go broke and not pay you back. But there are always exceptions. Moving on. So back to Monte Carlo. This is about variable selection, as I mentioned earlier, and after muddling through it. This is about being able to figure out what variables contribute the best, and figuring out is it going to be because of how long they've been in business, what does their financial structure look like, and so on. So I'll go ahead and step through this version of it as well. So we can go ahead and step, and it loaded it. So we've got a data frame. We're doing a similar sort of thing of sampling 1,000 rows with replacement, and then basically doing a binomial fit, it looks like on this one, and then we take a look at the model, then step through it. Take a look at the model, and you can see kind of the formula that comes out, and again, years in business is the first. So again, not surprising that how long somebody's been in business is what it is, and this is actually quite useful whenever you're trying to figure out what stuff is actually impacting the outcome the most, and that's it's not all that challenging to have too many variables, too many features to figure out, well, what's actually moving the needle, right? So that's an important thing to do. So moving over, I'm trying to remember what this one was. I did it a bit back getting ready for this. Okay, and this is showing you actually the true using a loop, right? So we're going through loading up the same file and then printing out the mean of the loan amounts, which is 187,000. And that wasn't terribly useful. And then probably should have like done a, what is it, print or something? Is there a display? These too many environments. Print. No, that's not very useful. Anyway, so the basic idea here is we're going to loop through this, calculating, pulling 1,000 at a time, figuring out what the average is, and figuring out how well it approximates the real value, and then see what those values look like. Oh, that's just showing this is empty. That's what I was showing. And so we can see what the various averages are based upon that selection. And this is something you would do if you, for some reason, couldn't compute the actual average, or maybe you need to do enough to get a sense of the sampling. And then the basic idea is you've got essentially a collection of averages. You then take a look at what's the average look like on those, right? So what's the mean of the mean, and so on, and what's the mean of it versus, and you can see we're approximating it, getting fairly close, and the min and max of the approximation. So that's the basic idea, is that sometimes a simulation is good enough. We happen to, in this case, know what the real average of the entire amount is, but using a sampling approach, we can get reasonably close with an approximation. So of doing some sampling, and it's because sometimes it is impossible to do the real calculation. And with that, we'll go ahead and switch over and do some SAS. Are you familiar with SAS, John?
Yes. Yep.
Okay.
We've used it in a few of the courses so far in this, curriculum. So I think that of the three, it's the least familiar, but I'm getting to like it the more I use it.
Yeah, I kind of am surprised it's still around, but that's just me.
Well, am I? It strikes me as about a 50 or 70-year-old programming platform, but it still works.
Yeah,
so,
it's old.
Just, R is so forward and Python is so powerful. It's just,
yeah,
way to get these things done.
Yep. Well, and it does, for some people, it's pretty powerful, right? But it doesn't help that the SAS Institute has been so controlling and not allowing people to have their own implementation of SAS, right? So I don't think.
Yeah, they have definitely turned their back on the open source community, and that's going to harm adoption in the long run.
Yeah, yep. And so that's what this is kind of cool. I think WPS is actually a British company, and they won in their Supreme Court a ruling that allowed them to do this. So I don't know that I'm actually supposed to be doing this here in the States, because I don't know that they've won here yet. But anyway, it let me download it, and I'm not going to make any money, so the damages will be pretty easy to calculate. So here it is. Anyway, here is the SAS program. Again, we're creating a data frame essentially with the 7 values, and then you can see the output that we actually have created it, and then we're basically doing the proc survey select to go through and pick essentially 5. Interestingly enough, SAS seemed to like -1. WPS needs a positive number for some reason. So anyway, we give it a seed and let it run, and it produces the samples of 5. I thought it was 5. Looks like, this seed was 1, sample size is 5, but we get 3 in that one for some reason. Interesting. But here's the 5, and interesting enough, G was pretty popular there. Not sure quite why that would be. And then similar sort of experience, running it again. And that's just repeating what it did before. So there it is in there it is in SAS. Yeah, it's an interesting language, that's for sure. It kind of reminds me of, I don't know, Fortran maybe. I don't know. It looks familiar.
Yeah, yeah, it's got that golden era of computing feel to it for sure.
Yeah, a little bit of COBOL thrown in there maybe. Anyway, um,
Mhm.
yeah. So let's see if this will work too. Similar experience with the small biz data set, and looks like that worked. Then again, picking 1,000, and we can see that it did it. And then run the print it out and run it through again, and we can see the output again of the random selection of it, and then the proc logistic, and there we go. Hopefully it finishes. I skipped right over it. I skipped right over it. So anyway, step 5, step 4. Okay, I did skip right past it. Step 1. Interesting that it picked something else as being kind of the interesting one. Interesting. So anyway, that's SAS. So at that point, we've talked about it. Now let's go ahead and shift back and talk about the deliverable. Where did it go? First deliverable. You guessed it. Apply Monte Carlo to solve a problem. And you're a data scientist, and so on and so on. So basic instructions: select 2 out of those 3 languages. If again somebody wants to do Rust, I would probably entertain that. It's practically Python, right? Go a little harder. So anyway, so the basic idea here is to create at least 10 simple random samples of at least 25% of your data, using your choice of with or without replacement. So I was thinking about the math on that. So 10 simple of at least 25%. So I'm not sure how with no replacement works there. But anyway, because I would think the number would be 4, right? So anyway, so you
Yeah.
so probably want to do with replacement. For each sample, create a probability and a default model that incorporates the variable selection, then make a note of the variables that you selected, and then analyze it, and which variables were least likely to be selected. Sounds a little familiar, right? We kind of just did that. Assess whether the chosen language or model approach had any effect on the variable selected. Probably would do that by considering if you get the same result from 2 different languages, which probably isn't very likely unless one of those is SAS. Anyway, what do you want to submit? It doesn't have to be .text, but the source code, it can be a .r, .sas, .py, .ipython, or whatever it is for the notebooks. Also, a Word document that contains the screenshots. That's kind of important so we can see the output, although I should be able to reproduce it. If for some reason you have unique data, either point me to it or share it with me as well. And then a brief memo in Word format that talks about it. So describes your method of sampling, how you developed your model, and the variables that were selected as the most predictive. And then comment on the noticeable differences in any variable chosen, if there's a difference between the languages, or perhaps slight subtle differences in your model implementation in a given language, although hopefully there aren't. And then what did you observe, and make sure to, and I stopped writing. I wonder why I did that. So let's go take a look at what I'm supposed to say while I'm doing that. Any questions about any of this stuff?
I thought the assignment was pretty straightforward. The one thought that I had was rather than give you two documents from Microsoft Word,
Yeah.
if I could give you, the screenshots in the memo where I just kind of describe what the output is telling us,
Yeah,
that
that'll
would
work.
feel a lot more natural.
Yeah,
Okay,
yeah, it makes
cool.
sense. Yeah, yeah, incorporate it and make it a unified sort of thing.
Yeah,
Trying to figure out what I'm doing. Yeah, that's fine. And
cool.
it did seem pretty straightforward. If for some reason you get stuck or whatever, let me know. That's
Oh yeah,
yeah.
I'm asking for help if I get
Okay.
stuck for sure. The PDFs in the assignment for this particular module I thought were really helpful too. So it's kind
Yeah.
of nice to not do stuff multiple ways.
Yeah, this one's a little. Oh yes, state this explicitly here. That's what I dropped off. So anyway, this course is pretty well laid out. The examples all seem to work. That's good. It's not always the case, sadly.
Yeah, that's
Uh,
we're all learning.
well, things change too. So especially if you don't pull it
Yeah.
in and you link to something, it may disappear. Also, the data files here seem pretty good. That's again not always the case, and the
Hmm.
module files seem pretty good too because they include generally like I think it's here the very end they give you all the source files, which is pretty cool.
Yeah.
Sometimes you have to actually do like see it on the screen and type it in things so that you can reproduce it. So anyway,
Yep.
so with that, I guess if there aren't any other questions, we can wrap this up. And if there's any topics you want to talk about going forward, feel free to let me know either now or later, and then we'll go from there.
Yeah. This sounds really interesting, and I like the way you're laying it out with the overview on Thursday and then the deeper dive on Tuesday.
Yep.
And the time that you're doing it is great because I
Okay.
can typically make a 5 Central, time work.
Okay.
Uh,
Good.
and then the thing I've been thinking about all week is, bootstrapping and then this Monte Carlo sampling feel very similar to me. So I was thinking, either today or maybe next, on Tuesday, we can just listen to you talk about the similarities and differences between the two concepts. Because I know that with sampling we're doing it with more variables, right? But what you're doing to each individual variable seems kind of similar.
Yeah. 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 Well, Monte the name sounds more complicated, right? But I mean, it makes sense whenever you look at it. But at the same time, we do this
Yeah.
in other ways all the time. You might call
Hmm.
this creating a model and simulating it, right? Letting it run for a few iterations, right?
Right.
I mean, it's what we do, right?
Blurry line, right?
Yeah, yeah.
Yeah.
Well, and I've taught courses on simulation before, and it's not all that different, right? I taught a course where
Okay. Yeah.
we focused on discrete event simulation, and same basic thing. You build a model, and you occasionally randomly generate stuff and put into it, and then you see what happens to the stuff that's already in it, right? In an iteration,
Yep.
same kind of thing. So uh, pretty straightforward so far. So anyway,
Awesome.
all right,
All right.
okay.
Well, appreciate that. I kind of had a feeling that the Venn diagram was at least like a MasterCard logo, so uh, the lines are a little blurry.
Yeah,
But appreciate you doing this, and I'm going to bang on this assignment a little bit this weekend.
cool. Sounds good. All right.
All right.
I look forward to seeing it. And stay
Bet.
safe. And for those of you watching the recording, if you have any questions, let me know. And we'll talk again on Monday.
All right.
Sounds
See you
good.
later.
Have a good evening.
Mhm.